Welcome to Govware2022. Applications are essential to our daily life. It is a critical asset for all of us as well as for organization. Hence, for organization, it is critical to ensure apps are robust, secure, fast, and appealing to user. To maintain a robust, secure, fast, and appealing apps, it is important to ensure those apps are frequently released in a timely manner. Apps releases need to be supported by a solid software release methodology. Today, I'm going to demonstrate how organizations can leverage a software lifecycle toolchain to operationalize a modern apps delivery with continuous integrations and continuous deployment to provide a seamless and smooth software delivery to production. These demonstrations will leverage a sample modern financials application, which consists of many microservices and will be distributed across many sites from edges to cloud and to data center. This showcase will demonstrate how you can achieve a consistent security protection across your applications and API. To operationalize and secure these distributed applications with hybrid edge is complex and difficult. Let's see how we can do that with F5 Distributed Cloud. Before I get into the demo, here is the high-level apps delivery framework with the emphasis of governance, control, and automation. The entire app delivery lifecycle follows the lifecycle from day 0, day 1, and day 2. This framework encompasses build, change, and operate methodology. Day 0, a series of guardrail, security control, and principle are defined, documented, and rationalized. The objective of this day 0 and phase is to provision an infrastructure or platform that's supporting those software's release lifecycle with security sandbox in the design. For example, application sandboxing, API security, and API discovery are well defined and understood. This framework aligns to the industry best practices as well as leveraging best-of-breed security tools set in the market. On day 1, I'm going to deploy a modern application called Acadia Financial across a fleet of sites. Day 1 activities are related to frequent release of code, pre or post changes to production or non-production environment. New software releases features can be leveraged this pipeline. When issues are encountered, either security-related or application-related fixes, developer or application owner can seamlessly fix and release code to production with the assurance that it gone through a proper automated release pipeline, which consists of testing, security scanning, and end-to-end code validation before implemented in production. On day 2 is related to operations the entire environment at scale. This encompasses operations governance where it ensures a set of policies and procedures are enforced and effective, security monitoring, SRE operations, compliance monitoring, and so on. Let's start the software release cycle with day 0 with infrastructure provisioning with security sandbox. Here are those steps where you provision, define, connect, and secure the infrastructure from checking the image integrity and install software to the definitions of the security protections from layer 4 to layer 7. Once infrastructure provision, developer can start to deploy apps onto the environment, which is day 1. CI/CD operations start when developer trigger a pipeline job via a code commit into Git repository. CodeSpark shiphead will trigger a deployment of Argo CD manifest. Argo CD is a modern GitOps continuous delivery tool for Kubernetes. This Argo CD manifest will trigger microservices deployment onto F5 App Stack on DC1 and DC2. During deployment, secure container image will be pulled down from private image repository. Money transfer and refer friends microservices will be deployed on DC1, and backend microservices will be deployed on DC2. CodeSpark will then trigger another API call to F5 Distributed Cloud control plane to deploy front-end microservices on Virtual Kubernetes. Virtual Kubernetes is a Kubernetes-compatible API for centralized orchestrations of applications across a fleet of sites. It's allowed you to group your sites, 10 to hundreds of thousands of sites, into a single logical group and manage them as a single entity. As part of this deployment, CodeSpark will also automate and orchestrate the deployment of F5 security services such as WAP, API security, and bot defense onto the environment. Governance and guardrail defined in day 0 will be enforced and in position to monitor, secure, alert, and operate. As a result of this, all deployed microservices will be able to communicate with each other within the confinement of those policies enforcement. In development or staging environment, a desk scanner tools can be used to validate and test the security control. Desk report can be fed back into a control loops to re-trigger the full CI/CD process to refine and re-baseline the overall security control. Upon successful continuous scan and pass the scanning tools, similar codebase can be released to the production's environment. On day 2, NetOps, DevOps, SecOps, or application owner can manage and monitor application deployed via the F5 Distributed Cloud Console. Here are sites deployed across the island. Currently, they are all healthy. This is a service graph observability obtained from F5 console. It gave a clear visibility on where are those sites located and the services interactions of those components of the apps. In this demonstration, Acadia Financial's application consists of 3 major components: front-end, money transfer, and refer friends microservices, and back-end microservice. All those components are distributed across various sites. Here is an API graph that represents those known and unknown API discovered via API service discovery capabilities. Let's proceed to the demo. Here is the demo environment. Let's have a quick walkthrough. Day 0 on infrastructure provisioning already completed. Here are all the sites currently deployed, and it is online and healthy. I have a CodeSpark screen. In this screen, I will trigger a CI/CD job. This is a screen for the DevSecOps where application load balancing and security policies such as web application and API protection can be automated. In this browser, I have F5 console. Currently, there is nothing provisioned yet in the load balancing or in the origin pool. Here is a developer screen where developer has a Git repository, has a private image registry to store secure images as well as GitOps tools. This is the end user screen. Currently, the application is not accessible from anywhere. At the bottom of this screen, this is a virtual Kubernetes. I constantly monitor the resources on virtual Kubernetes, which consists of AppStack on AWS, Azure, and ruggedized hardware. When the CI/CD triggered, resources will be provisioned on virtual Kubernetes. Similarly, this is DC1 and this is DC2. Currently, nothing's running. As a developer, I'm going to deploy my newly created application. CodeSpark will trigger the deployment of day 1 on this new application. This CI/CD will deploy front-end apps on virtual Kubernetes as well as deploy Argo CD manifests for refer friends and backend microservices. As a result, application will be deployed on virtual Kubernetes and refer friends on DC1 and backend on DC2. Argo CD will orchestrate the deployment of apps onto respective site. Currently, all are runnings. Although applications are deployed, it is not accessible from the internet. DevSecOps can run an automation script, in this case Terraform, to provision or advertise those applications to the internet. Now DevSecOps is going to run this Terraform scripts to provision all the necessary security policy, load balancing, as well as the API protections on this particular application. You can see API gateway for the backend, API gateway for the refer friends, Arcadia backend, front end, and refer friends. All those are created. Now, the applications are live on the internet. Now I can do a login. You can see that this application is running. Invite your friends as shown properly displayed. Money transfer is a new services that not available from the internet yet, hence is coming soon. Let's create a few transactions. Let's buy some stocks. F5 stocks. You can experience these applications fully operations. You can see that it is working. Now, application owner need to release a new module called money transfer, and it is ready to be released to the internet. Now, developer going to use CodeSpark to trigger a money transfer module onto DC1. Similar as just now, CodeSpark deploy on Argo CD manifest. As a result, Argo CD deploy money transfer onto DC1. Money transfer microservices on DC1 currently in a running state. If I check the application, money transfer module still not available from the internet, although that the Arcadia Financials applications allowed from the internet and money transfer module already deployed and running on DC1. This behavior was intentionally architected as part of the day zero guardrail. DevSecOps required to take actions to permit that specific module to be alive from the internet. This can be controlled via the Terraform play. Now, DevSecOps trigger this Terraform play. If I refresh, you can see that once the Terraforms being applied, you will be able to see the new HTTP load balancer, the API gateway for the money transfer, as well as the Arcadia money transfer load balancings are created. Now, the application fully alive. Money transfer modules available from internet. If I refresh the browser, you can see that there's a send money to, as well as the quick money transfer. These applications are alive from internet. Let's create some money transfer transaction. For example, click one, send to a friend, let's say for example to Tony, let's say send 900, transfer now. I successfully make a fund transfer or money transfer to Tony of 900. Now, the scenario is one of the released module vulnerable to zero-day attack and require immediate action. This module, GoFinance, is vulnerable to Log4j. In this demo, I intentionally allowed this Log4j attack to happen so that I can demonstrate how an attacker can launch an exploit to the apps and successfully gain control of the apps. In the productions environment, F5 SaaS Web will automatically block zero-day attack without actions from user. Now, here is my attacker screen. Let's try to exploit these vulnerabilities. From the attacker screen, I'm going to run this attack vector, as well as have a port listening on 9001. Attacker will copy this string onto this application and click login. You can see that from the attacker screen, there's an outbound connection from the application to the attack vector here. You can see that there's a connection received from here. So if I check hostname, you can see that this is a port which the attacker managed to compromise. If you look at SRDK8, that is here. If I run who am I, I'm root, IPA, and you can see that I completely command and control this particular application. This shown that the attacker successfully compromised and gained root access to the application. Now, let's fix it. Let's fix the configuration. Now, that setup can change this blocking mode from false to true, and if I rerun the test again, the log4j will be blocked by F5 warp. Let's rerun this exploit again. You can see that this exploit's been blocked by F5 WAF. This is how an organization can leverage F5 Distributed Cloud solution set with continuous integration and continuous delivery to shift left and deliver new code to production in a fast and secure manner. Now, move to the day 2 operations, where what a platform or operational guides they can see from the F5 console. Now, if I go to the web application and API protection, under the security, I can monitor the usage, the total attack, the total request, and the total block. For example, if I go to the Acadia front end, these are the visibility traffics that the platform owner or the application developer or the SecOps that can see from the security event. It's shown where the attack source coming from, what is the top API endpoint, as well as whether it is a bot or not a bot, and what is the attack signature and the attack type. The log4j remote code execution is what I executed just now. And it will give you the malicious user IP addresses as well. This is for the SecOps view. Let's say, for example, the DevOps, they have view as well. If I go to the load balancer or distributed apps, you can see the app traffic's distribution from where to where. For example, this one show that currently from the public internet, it hits either AWS H1, Azure H2, or ruggedized H3. And all this front-end web server will talk to the backend on the DC2. This is the backend, and DC1, this is where you have your reference and your money transfer modules talking to the backend on DC2. On the service mesh, you can see the interactions of all those applications in a microservices view. For example, front end talking to back end, front end talking to the money transfer. If you want to know the services, you can double click on the link and see how's the service, how many error, how many requests. For operations to look into a more detailed fine-grained information, they can look into the request service. For example, under the request, they can see all the error code from 100 to 5xx. And here are all the details of the request. Feel free to reach out for further discussion, and thank you for watching.